Alright, welcome back. So again, where we left off is we're trying to solve for the a value here, so we're going to sub in the point for x and y, and that will leave us with a as the only unknown, so we should be able to solve it. So the x value is -7, the y value is 4. Let's see what we get. So I get 4 equals a, -7 plus 3 squared plus 5. Okay, and one of the big mistakes I see from here on in is just not being careful, not following BEDMAS properly. So let's simplify inside the brackets first. Okay, so inside the brackets I have -7 plus 3, which is -4. Okay, and then -4 all squared is -4 times -4, so positive 16. So I have 16 times a plus 5. Okay, and now it looks like a much simpler equation to solve, so I'm going to subtract 5 from both sides of the equation to wind up with 4 minus 5, which is -1, 16a. And then last but not least, I'm going to divide both sides of the equation by 16. Which tells me I have an a value of -1/16. Okay, so when that's all said and done, I can now write out my final equation in Vertex form. So it's going to be y, or f of x. Let's use f of x because we're in grade 11, function notation. So it's going to be -1/16. And then again, I had x plus 3 all squared plus 5. Okay, so all that work gave me the equation in Vertex form, and normally I'd be done. I'm happy to have an equation for the quadratic. This particular example wants us to put the final answer in standard form. So notice that we didn't directly start with trying to find standard form. It was too complicated. And, in general, we won't necessarily say which form to find the equation. You'll have a choice. You always want to make sure you're making the wise choice. So based on what's given, here I'm giving you the vertex, create vertex form. If I give you the x-intercepts, create factored form. In this case, it wants a final answer in standard form, but it's easier to start with vertex form based on what was given, and then just expand and simplify to get into standard form. Okay, so going from here into standard form isn't too bad, but it does take some algebra. So just be very, very careful again that you're following proper proper rules for expanding. So for example, again, I've said this tons of times, and I'll probably say it again tons more times. X plus 3 squared is not equal to x squared plus 9. Okay, it's not true for numbers. Let's say we did 3 plus 2 all squared. Okay, you would not tell me that this is 3 squared plus 2 squared. Okay, 3 squared is 9, 2 squared is 4. That's equal to 13. But we know that 3 plus 2 is equal to 5. So this should be 5 squared, which was 25. So you know it's not true when it's numbers, so don't start assuming it's true if there's just because one of the terms is a variable. Okay, so remember this. Do not just assume this is x squared plus 9. Do not make that mistake. It's a very common mistake. Let's try to avoid that. Okay, you make those kinds of mistakes, and sometimes it makes, if you have to do more work with the equation, it can make it unsolvable. Okay, and the solution being the wrong answer, it might make the rest of the question impossible to do, or at least or at least a lot harder. So to expand this out, we're going to start with the x plus 3 all squared. Remember, this is equal to x plus 3 times x plus 3. And how do we expand that out? Well, we use an array or we use the distributive property, either one. Okay, I know some of you have a tendency to want to, when you're doing something like this, to multiply -1/16 into one of the brackets before you use the array. Again, not that it doesn't work. It does work, but it introduces fractions earlier on in the steps, and I know that a lot of us don't like fractions, so let's avoid using them as long as we possibly can. So let's use an array with x plus 3 times x plus 3. So that's going to give me x squared plus 3x plus 3x plus 9. Okay, which when I put together is going to give me, after I put my -1/16, x squared, I got two 3x's, which together give me 6x plus 9 plus 5. Okay, and then from here, remember this is all in brackets still. I multiply -1/16. I'm going to distribute it through this bracket through multiplication. I'm going to have -1/16 x squared. Okay, -1/16 times positive 6 is -6/16. I know that reduces. I'll reduce that on my next step. Okay, and then I have minus 9 over 16 plus 5. Okay, don't forget that plus 5 that was hanging around. That's not multiplied by negative 1 over 16. It's not in the brackets. And then I just need to finish simplifying. So negative 1 over 16 x squared. This simplifies both top and bottom divided by 2, so I get minus 3 over 8x. I get minus 9 over 16 plus 5. 5 is 80 over 16, so multiplying, remember this is 5 over 1, so multiply both numerator and denominator by 16, get 80 over 16. So that winds up giving me 71 over 16. Okay, so it's not a friendly looking equation in standard form, but it works. Okay, we can check our answers up here. We can see that we are correct. Okay, so this would be our final answer in this case. Okay, now in general, if I don't specify which form, again, you can choose whichever one you like, and again, go with whichever one's easier to make. Okay, let's keep going. So another one where you have to find the equation of a quadratic in vertex form. Here I'm giving you that the maximum value is 5 and giving you there's x-intercepts at 4 and negative 8. Okay, I'm going to let you guys try this one on your own first, either on your own with a small group. So work through it and push play and ready to go through the answers together. Okay, so you can take a quick look at the answer here, see if you're on the right track. So just to go through the steps, again, I'm looking for the quadratic in vertex form. I'm being given the x-intercepts here, so if I wanted to, I could actually start by trying to build a factored form. But there actually is enough information here to actually get the vertex, even though it's not necessarily explicitly given. So I'm being told there's a maximum value of 5 here. So the maximum value is the optimal value which comes from the vertex. It's the y value of the vertex, which means in vertex form, it's the k value. So right away I can put in a k value of positive 5. Now, again, I didn't tell you what the h value is, or the x value of the vertex, but we can find x. Remember, the x value of the vertex is the axis symmetry. And the axis symmetry is halfway between your x-intercepts, which are at 4 and negative 8. So if I average those two values, 4 plus negative 8 divided by 2, I get an axis symmetry of negative 2. I put that in the equation for h. And now I'm in a situation where the only missing value for my quadratic in vertex form is the a value. Okay, so what did we do with the last example when we had to solve for an a value? Well, we subbed in a point that we knew was on the quadratic. Well, we know a point that's on the quadratic. We actually know two of them. It's two x-intercepts. So we have two possible points we can use. We have an x-intercept at 4, which remember is the point 4, 0. It's the x-intercept, so the y value is 0. Or we have the point negative 8, or sorry, the x-intercept at negative 8, which is the point negative 8, 0. So you can sub in either of these 2 points in for x and y and solve for a. I personally chose the point 4, 0 because it was easier to work with. There was no negatives involved. So it just makes the math slightly easier to work with. So I sub in 4 for x, okay, 0 for y, and then I can solve for a. So I'm following BEDMAS here. 4 plus 2 is 6. 6 squared is 36, so I get 36a plus 5 on the right side. And I subtract 5 from both sides of the equation. Then divide both sides of the equation by 36. So I get an a value of negative 5 over 36, which then gives me that for my final equation in vertex form. If you started by creating factor form because of the x-intercepts, that's fine. You would have had some a value, and then you would have had x minus 4, x plus 8. But again, in order to find a point to sub into the equation to solve for a, you would still have to have found the vertex, because you have the maximum value of 5, find the axis symmetry that goes with it, which is negative 2, so you'd be subbing in the point negative 2, 5. Okay, but once you know that you have this point, which is the vertex, well, why not just create vertex form? It's just going to be a little bit easier for you to work with. Okay, so anyways, another possibility, so there's another type of example of trying to solve for the equation of quadratic in vertex form. Okay, let's take a look at one more. Okay, so now I'm giving you an equation. It's in vertex form. Looks a little bit uglier, of course, because of all the fractions, and I just want to determine the zeros. Okay, so one of the ways used to finding the zeros is to put it into factored form, which would involve expanding this and putting it into standard form, and then trying to factor it from there. That's a bit of a long process, especially with the fractions involved, so let's try and take an easier approach. Remember last unit, I said the unique thing about vertex form is there's only one x inside the equation, which means in theory we should be able to solve for our x if we need to. If we have a y value, we can solve for x. So if I'm looking for the zeros, remember those are the x-intercepts, which means that y is equal to 0. So I know I can sub 0 in for y, and then try and solve for x. Okay, as ugly as it looks with the fractions, it's actually not too bad. So what I'm going to do here to isolate for x, first thing I'm going to do is I'm going to add 33 over 8 to both sides. Okay, so again, that's going to simplify this equation a little bit. Okay, and again, if I'm trying to isolate for x, well, what's in the way? I have this square that's on the bracket, but I also have this 2 outside. If I can't take the square root, I have to take the square root of 2 as well if I were to take the square root right now. So right now I'm just going to divide both sides of the equation by 2. Okay, to get those 2's to cancel. So I'm going to have 33 over 8 divided by 2. Remember, using fractions, this is 33 over 8 times a half. Apologize for the messy handwriting here, which is 33 over 16. Okay, and now that all that's left is that squared bracket here, I can simplify by taking the square root of both sides of the equation. Okay, so this is going to give me plus or minus, don't forget the square root, you're taking the square root of both, don't forget the plus or minus, you're taking the square root of both sides of an equation. And that's going to be equal to x plus 5 over 4, which, when I subtract 5 over 4 from each side, finally gets me an answer for x. Okay, so I wind up with x equals plus or minus the square root of 33 over 16 minus 5 over 4. And you might be thinking, this is a really ugly answer, but it happens to be correct. Okay, remember, this means you have two possible answers. X equals the positive root of 33 over 16 minus 5 over 4, and another one where x equals the negative root of 33 over 16 minus 5 over 4. And you might be thinking, with an answer this ugly, well, how would I ever have gotten this by factoring? And the answer is, well, you wouldn't. Okay, so normally, if we had an equation in standard form, we want to find the zeros, we would have to look at factor form, but it's not always possible. So just for an example, I just want I want to show you the standard form of this example right here. Okay, so actually, as an exercise, I'm going to have you do, I know it's ugly with the brackets, with the fractions, but try and put this into standard form by using expanding and simplifying. And see what you get for standard form. Okay, I'll go through it together with you when you're ready, and you can push play. But I just put it in standard form, and I'll show you what happens if you try to put this in standard form, and see why we can't necessarily find the zeros from it directly. Okay, so there's the final answer in standard form. It looks a lot nicer actually than the vertex form. But again, I expanded the x plus 5 over 4 all squared using an array, and it's the same idea, just working with fractions right now. I multiplied through the bracket, distributed the 2 through the bracket, and then collected my like terms, and I went up with 2x squared plus 5x minus 1. Now again, if I gave you this and asked you to find the zeros, you would normally be trying to factor it. Okay, there's no common factor here, so you'd put 2x squared up here, minus 1 down here in the array, and you'd be looking for two numbers that multiply to negative 2, but add to the x values, which is positive 5. We can try as long as you possibly want. There will be no paired numbers that makes this work. So this one does not factor. So getting the factored form for this is not exactly something that we can reasonably do at this point in time. We'll look at other ways of doing it. So right now, from vertex form, the best way to find the zeros is to set y equal to 0 and solve for x, just like what we did up here. Okay. Putting it into standard form is not always going to get you the right answer, because we can't necessarily factor it from here. Unlike the ones last unit, which always did factor. But now that we're doing more complicated ones, you have to keep in mind that you're always looking for the most efficient way of solving. In this case, it is setting y equal to 0, rearranging the equation, solving for x. Okay, you'll never get an answer like this through factoring, because it will take you forever to come up with that pair of numbers that will work. Okay, so that's it. That's all. Okay, the homework is still as listed on the worksheet that you were doing yesterday during your investigation. There's a good amount of it there. Excellent practice. Please work through it, and let me know if you have any questions. Okay, that's it. That's all. Cheers.